This is chapter 18, example 2. What we have here is some circuit that looks like it does some multiplication. A 2a and a 2b, I see that in the output. Of course, we don't know how to do multiplication, but we do know how to use an adder to get that result. So that's okay. Trying to figure out the interface this thing. I see that it has an 8-bit volume output, 2 8-bit inputs, and I think that's it, so we'll write that down as step 1. And it's a fits also. A nice part about this problem is we don't have to worry about checking for validity on this. We can assume it's always valid on the output. A couple things going on here. Next step here, what we need to do is take an inventory of the circuitry we need in here. And there's, quite frankly, there's a lot going on. Doubt I'll get this right the first time, but I'll go back and repair it. I call it done. So the output is either generating one of two values, which is the 2a or the 2b. Let's plop that down there because it's making a choice. It's choosing between one of two values. It's either choosing between 2a or 2b, which means need some math or some ripple carry adder to add either 2a or 2b. And so there's just a ton of different ways to do this. I'm going to pick one way and go with it. The nice part about this problem is it didn't constrain me to how many ripple carry adders I could use. I'm going to go ahead and not try to limit the number of ripple carry adders to something low. I'm just going to, for the first pass at least, I'm going to make it less intelligent. There we go. Okay, so what I need to do for these two inputs is either a 2a or a 2b, which means I'm going to use two ripple carry adders here. One is adding the 2a values and one is adding the 2b values. I know I don't need to do this, but just for simplicity, I'm going to go ahead and take this approach. We're not going to worry about the carryouts on these things because the problem said not to worry about it, so I'm not going to worry about it. But what we do have here is a mux with a control input that needs to be assigned to something. So what it's saying is two conditions make the choice whether it be 2a or 2b. And the thing is if the sum of a plus b generate a carryout, that means I need another ripple carry adder. Here's my a and b, and I don't really care about the sum on this one. I care about the carryout. Okay, so there's my carryout. If it generates a carryout and are equal, so once again, I need another circuit in here, which is a comparator. These are all 8 bits, and I need an EQ. And if it generates a carryout and are equal, and there's my AND gate, it practically calls out for that AND gate right there, and I'm going to go ahead and connect this here. And then take a guess on this. I'm mostly done, but I need to check whether my guess was. So if it generates carry and they're equal, it chooses 2a as the output, which is wrong. It was a bad guess. Okay, so it's 1 and 0. Okay, so if this is a 1 and this is a 1, meaning that a plus b generated carry and they're equal, I want to choose 2a. My guess was wrong initially, and so I've corrected that and it's happy now. We're almost done. What I have to do is decide whether or what's controlling this circuit. And this is the control input for the mux, and what is that connected to? It's connected to an internal signal, so this circuit has internal control. And with that, I am going to call it done.